beli buku kan? Sekejap. Dia tengah rekod. Okay, tengah rekod. Okay. Sekarang ni saya tengah presenting. Okay, can you see my screen?
Yes.
Okay.
Can you see my screen? Okay, alright. So this question I have sent to you through Telegram. Okay, ada dua question kat sini. Question 4A ni we're not going to discuss today in class, but we will save it for insyaAllah tomorrow. Okay. So soalan ni soalan simple pendulum, tapi dia 12 markah, 6 markah untuk question 4A Roman 1, lagi 6 markah untuk question 4A Roman 2. Question 4A Roman 1, write the equation of motion, determine the period of the small oscillation if the disc is free to rotate at A. I rasa you all boleh buat. Okay, question number 2 is tricky sikit. Dia kata write soalan yang sama, write the equation of motion and determine the period of the small oscillation if the rod is reverted to the disc at A. Okay. So that one kita hold on dulu. Sekarang apa yang kita nak fokus hari ni ialah question 4B ya. Yang kita nak highlight kat sini adalah question 4B ni yang kita nak buat hari ni. Okay, so I'm going to read you the question. Okay, figure question 4B shows a double pulley. Okay, there is a double pulley having a total mass of 15 kilogram and centroidal radius of gyration 150 and 250. Okay, so ada double pulley. So nampak tak ada pulley dekat connect to block A. Pulley yang connect to block A is using the outer radius. Pulley yang connected to block B is using the inner radius. And then the mass of the pulley is 15 kg. Okay. Block and B are attached to the cords that are wrapped around the pulleys. Okay. The coefficient of kinetic friction between block B surface is mu K equals to 0.25. Okay, so this is kita punya friction surface. If the system is released from rest, so kat sini dalam soalan dia dah kata, if the system is released from rest, determine question number 1 ni, Roman 1, write the equation which relates to the speed of the blocks A and B. So dia nak equation yang relate to the speed of block A and block B. Tapi relate with angular speed omega. So kita kena relate dengan angular speed omega. So what formula do you think that you need to use yang ada V dengan omega? Can you tell me? V equals to apa?
R omega.
Yes, V equals to R omega. So if we want to find VA, it will be R omega, RA and omega. So kita punya R, okay, if you notice block A is connected to the outer radius. Our outer radius is 250 mm. So 250 mm we must change to meters. So it will be equals to 0.25 omega. Okay, and then if you want to find for velocity of block B is radius for block B multiplied by omega also. So radius of block B is joined with the inner pulley and the inner pulley radius is 0.15 omega. Okay, so that is answering for that first one. And then after that, they ask you to find the vertical distance with angular angle. So they ask you to find the distance SA, SB berapa tapi related with the angle. So what formula is S yang ada angle? Do you remember the formula? What formula? Ni S. This is the theta. This is the R. The distance R.
S equal to R theta.
Yes, that is correct. Okay, S equals to R theta. So if we want to find SA, it will be RA theta. So RA is again same 0.25 theta. And then if we want to find SB, also the same, it will be RB theta. So RB is the inner radius 0.15 theta. Okay, now if you notice the marks given here is 2 marks. So this one you will get half a mark, half a mark, and then half a mark. and then the total marks will be 2 over 2. Okay, all right. So now we will proceed to the next question. Okay, now what is the next question? Okay, so that is how to answer question 4B Roman 1. Okay, now we're going to proceed to the next question. Now, the next question is determine the velocity of block A. So they ask us to find velocity of block A when it strikes the ground. So when it strikes the ground, so if the block A is, we need to find the velocity of block A when it reach the ground. So this is our S. So our SA is 900 mm. We change it to meters, it will be 0.9 meters. So find velocity of VA when SA equals to 0.9 meters. Now, for this question, what method do you want to use? Do you want to use principle of linear impulse and momentum, or work and energy? Chana, what method you want to use?
Work and energy.
Yes, that is correct. So for this question, we need to use principle of work and energy. Okay. So for principle of work energy, if you remember, the formula is very simple, which is T1 plus work equals to T2. Now, for this question, they did mention in the question, and if I read back the question, if the system is released from rest, so does that make what happened to our T1? What will be the value
Zero.
for our T1? Yes, 0. So our T1 is going to be equals to 0. So now we need to find T2. Now, if you T2 is the kinetic energy, so if for this question, so what you can see is there is a movement of mass block A. Now, if mass block A is going to move down, what will happen to mass block B? Will it move to the left hand side or will it move to the right hand side? Now,
Left.
if yes, it will move to the left hand side. So then block B is also moving. And what happened to the pulley? The pulley is also going to be rotating with an omega, with a speed. Yeah. So it means that for our kinetic energy, the formula will be 1 over 2 ma va squared plus 1 over 2 mb vb squared. And then one more is the rotation, 1 over 2 I omega squared. Okay, so this is the formula for kinetic energy. Now, for the kinetic energy, if we try to because we need to make sure all the unknowns, all the all the value is in terms of omega. So we know what is V. V is R omega. V is VA is R omega A, VB is RB omega omega. So in the formula, it will be 1 over 2 multiplied by mass A multiplied by radius A multiplied by omega. Don't forget this one, you must put in a bracket and square root. Okay, 1 over 2 mass of block B, and then RB omega, and then square root plus 1 over 2 I. Okay, now how are we going to calculate I? Okay, now for this question, it's just a coincidence. Dia tertinggal value radius of gyration. So I'm going to assume for this question. So let's assume a radius of gyration K equals to 0.16 meters. Okay, so due to that, our I, if we need to calculate I, we have to use this formula, mk squared. Okay, so I will be mk squared multiplied by omega squared. So if you notice, um 1 over 2 and omega are the same. So due to that, what we can do is we can take those two value out and put in a bracket. So 1 over 2 multiply omega squared. So we are left with MA. So what is our mass of block A? What is our mass of block A?
12.5 kg.
Okay, I just want to ask because I want to make sure you're alert. Multiply by 0.25. Don't forget the square. Okay. Plus mass of block B 10 kilogram multiplied by 0.15 squared plus mass of the pulley. What is the mass of the pulley?
15.
Okay, good. 15. What is the K?
0.16.
Okay, 0.16 squared. Okay, now calculate for me what is T2. If we calculate T2 together, 12.5 times 0.25 squared plus 10 times 0.15 squared plus 15 times 0.16 squared. What do you get? Come on, I calculate faster than you. What do you get? What do you get?
1.39.
Okay, correct. 1.39. Okay, don't forget divide by 2. So T2 will be 0.695 omega squared. Okay, now that's done. Okay, so here we have answered what is T1, what is T2. Okay, now we need to get what is the work. Okay, now, so for this question, since we have two blocks involved, okay, oops, I will bring it aside here. We have two blocks involved, so what we need to do is find the work of block A and work of apa work of block B lah, friction force lah. Okay, so if we draw work of block A, so first we need to find work of block A. Okay. So if I draw block A, this is block A. So let's say it's connected to a pulley. So there will be due to weight lah. So work of block A, it will be due to weight lah. Okay, now so and then it must reach down here a distance of 0.9 meters. So work of block A is simple. So work of block A will be U1 to 2 will be equal to work of block A multiplied by SB. So very easy. So work of block A is same as mg. Oh, hold on. Will be mg times 9.81 times SB. So SB is 0.9. Okay. So take your calculator. 12.5 times 9.81 times 0.9. What do you get? What do you get?
110.36.
Okay. 110.36. Don't forget joule. Okay. Okay. Now that is work of block A. Okay. Now the next one for block B is work. Now this one is work of block A due to weight. Now next is work of block B. But work of block B is due to friction force. Okay, because if this is block B, now, so block B is moving that side, right? Okay, so the friction will be the opposite direction. So this is the friction force, and there will be a normal force, and then a weight lah. This is block B lah. So the friction force is nu kn. Okay, all right. So the work done for block B will be what? It will be, because it's the going the other direction, we must put negative. So it will be the friction force multiplied by SB. Okay, the friction force will be mu Kn multiplied by SB. Our, don't forget the negative. So the mu K is um 0.25. Okay, now N, we have to calculate N. Now N will be equals to W. Am I right? So W is mg. So N is mass times 9.81. So then it will equal to 98.1 Newton. So this one will be 98.1 SB. Okay, now let me just calculate this. 0.25 times 98.1. You get negative 2 for 24.525 SB. Okay, now we need to find SB. Now, if we go back here, okay, now how to find SB? Okay, how to find SB? Okay, SA is 0.9 meters. So how do you find SB? Okay, now, so SB, the formula is 0.15 theta. Do you know how to find theta? How to find theta? You can find theta from the formula of SA, right? Because you know SA is 0.95. So SA is 0.25 theta. We know SA is 0.9. So what will be our theta? So senang je lah. So our theta will be 0.9 divided by 0.25. So all you need to do is just find SB equals to 0.15 theta. You know the theta is equals to 0.9 divided by 0.25. So you can find SB. Understand? Understand tak?
Yes.
Okay, 0.5 times 0.9 divided by 0.25 berapa? Dapat berapa? Come on, my calculator is faster than
0.54.
54. Okay. That's correct. Okay. Okay, let's go back here. All right. So, oops. So negative 0 plus. Negative 24.525 multiplied by 0.54. What is the answer? Excuse me. So dapat negative 13. 13.2435 joule. Okay. Okay. All right. So so I think what we have done here, we have work of block A, work of block B. So now we can find um, the total work. So what is the total work done? So total work done is 110.36 minus 13.2435. So the total work will be 110.36 minus 13.2435 dapat 197.1165. Sama tak?
Sama.
Sama.
Alright. Okay, so now what we can do is we can find the we can use this the principle of work formula. We know T1 is 0, work is 97.1165, T2 is 0.695 omega squared. So now we can find omega. So what is omega? 97.1165 divided by 0.695, and then oops, not square root the answer. Uh, salah juga. Okay, dapat sama tak 11.82?
Dapat.
11.82, okay. Radian per second. Okay, so now we want to find the velocity of block A when it reach the ground. So senang saja, velocity of block A will be 0.25 times 11.82. So times 0.25, you will get the answer 2.9555, 2.955 meter per second. Or we can say 2.96 lah, meter per second. So this question, if we look back at the question, it is apa? 7 marks, yeah. So let's say you write the formula 1 mark, you find this 1 mark, 3, you find 1 mark, 1, 2, 3, 4. This one 1 mark, 1 mark, and this one will be the answer. So total. So what is the total? 1, 2, 3, 4, 5, 6, 7. So here 7 over 7. Okay. Panjang. Maka 7 je. Okay. Alright. Good. Okay. So now we proceed to the next question. Final question. Okay, let's read. Calculate the total distance that block B before coming to rest. So now kita nak fokus kat block B pula. Dia nak the total distance before it come to rest. Okay. So untuk this, for this question again, we are going to use so for this question number 3, it's gatal. It's total distance block B before coming to rest. Okay, now for this question, we're going to use the same method, that is work energy. So it will be T plus work equals to T lah. But now we're going to use T3 to T4, work 3 to 4. Okay, because we don't want to use the same symbol. But now we're going to focus block B ni saja. So when it comes to the rest, we tak tahu bila when it will come to the rest. So you need to find SB prime lah, a new SB. So this is block B. So dia sama, dia ada normal force, dia ada weight, and then dia ada friction force lah. Okay. Now since the total distance for block B before come to rest, so T3 will be 0 ke T4? So total distance of block B before coming to rest
Before.
before T4. Did you say before or T4?
T4.
Okay, that's correct. T4, ingat before tadi. So T4 will automatically be 0. So we need to calculate T3. Now how to calculate T3? So since we are only considering that part of the we're only considering part of block B, so our kinetic energy will be 1 over 2 mb vb squared plus 1 over 2 I omega squared. Okay, so 1 over 2, our mass of block B will be 10, V will be R. Okay, jangan lupa, wait, let me back balik. MB multiply bar RB omega, ni jangan lupa square, plus 1 over 2 M M M M betul M apa teh? MK squared omega squared. Okay. So 1 over 2, our mass of block B is 10. Our R is 0.15 times omega squared plus, oh, omega squared kita dah dapat dah. What is our answer for omega tadi?
11.82.
Oh, okay. Alright. 11. Oops. Oi. Sekejap Oops. Yeah. 11.82 squared plus 1 over 2 mass still 15 times 0.16 squared times 11.82 squared also. Okay, calculate. Okay. Eh, saya macam lain juga. You all dapat berapa? Oh, ni tertinggal. Squared. Padan lah. Okay, what did you get? Dapat berapa? Saya dapat 42.54 joule. Sama tak? Hmm?
Sama-sama.
Sama. Okay, now. Okay, done. So now let's do work for that block. So work for that block. Work for the block will be the same. Will be due to friction. Tapi kali SB prime. Okay, sebab itu yang kita nak cari. So this will be mu Kn SB prime. So this one will be 0.25 kali normal force tadi mg kan. 10 kali 9.81 kali SB prime. Okay. So dapat berapa? Kita dapat negative 24.525 SB prime. So now we can put into the formula because we have all the important values. So write down balik the formula. Okay, will be 42.54 minus itulah minus 24.525 SB prime equals to 0. So what is our SB prime? So 42.54 bahagi dengan 24.525. Okay. I got 1.7345.
Sama.
Okay. So 1.735 je lah. Okay, so now for us to find the total distance of block B, we have to buat SB plus SB prime. So SB tadi, if I remember, 0.54 plus SB prime. Okay. Oops. Oops. So 1.735. You get 2.275 meters. So it will be 2.28 lah. Okay, so that is the answer lah. Okay, so soalan ni macam lain sikit sebab dia melibatkan pergerakan distance compare from soalan yang kita buat tadi. So ni 4 markah soalan ni. So I would assume like, okay, this one you get 1 mark. This one also 1 mark. 1 mark, and then this one the answer 1 mark. So it will be 4 out of 4 lah. Okay, alright. So that's how you do it lah. Okay, so our next class we're gonna focus on a spring in parallel and in series. Kita nak fokus soalan spring, and then a new formula yang I ada cakap dalam teori tu, teori vibration, if you have looked in the video, okay, and then maybe we will discuss more questions on vibration. So tomorrow will be our last class. It will be very important before I last see you. So everybody understand how to do this?
Doktor,
Okay. Yeah.
kalau question tak kasih K, kita boleh assume lah.
I rasa mungkin yang ini dia terlupa bagi K, you boleh assume. Sebab tak salah. Mungkin soalan ni dia lupa bagi kot. Soalan ni dia lupa bagi. Okay, alright. So you can assume K. But for this question, saya yang tolong assumekan for you. I assume K as 0.16 meters. Okay. Kadang-kadang dalam soalan kalau dia tak bagi, dia akan bagi you bonus lah. Dan apa-apa you assume tu kita akan terima lah. Okay, alright. So don't worry. So we need to practice a lot. Okay, even though our exam is on 1 February, you can still ask questions that is related to the final. And if I can help and answer you, I will help lah. Okay, so itu saja for today's class. So just now kita dah manage to take our photo together. Betul tak? So dah okay lah kan? Okay, alright. So is there any other questions that you would like to ask before I stop? So I will stop the recording. So siapa yang nak tengok balik boleh tengok balik kemudian lah.